So now let's briefly compare additive manufacturing with the most popular subtractive type of manufacturing process these days. And these two are all automated. They all use computers on their machines and computers in the preparation stage. So we can easily compare these two. What about material? Can we use all types of material in additive manufacturing? Since, as you know, on CNC machines, we can use almost all materials, especially if you disregard just the brittle ones, but you can use most of the ductiles or soft metals, soft parts, plastics, sometimes composites, but not that much. But we have a high flexibility in terms of material for CNC machine. But for additive manufacturing, some of you have already noted there, we have some limitations these days. Right now, we have some specific metal parts, titanium, steel, aluminum, copper, but not all the metals can be, for instance, additively manufactured. There are companies working on the material improvement for additive manufacturing, but we have still limitations in terms of material for the additive manufacturing operations. So speed is a bit complicated issue in this comparison. So I want to actually hear your responses for the speed. What do you think? Which one is better in terms of speed? Or I can divide this question into two. If you consider the whole manufacturing time, starting from design to manufacturing, which one is better? If you consider the whole pipeline, design and fabrication pipeline, which one is much better in terms of time, let's say?
Depends on the details.
There are different answers.
CNC machining is better in design and production, I think, in case of speed.
But what about CAM part? In the complex manufacturing parts, depending on your on the complexity of your part, you need to spend some time for sub processes. You should tell that there should be, let's say, tool drilling operation, tapping operation, and shouldering operation, facing operation. You need to do a setup. You need to have some fixtures. You may need to design some special fixtures. So if you consider the overall design and fabrication pipeline from starting the design to having the final part, CNC machining takes lots of time. But if you consider the additive manufacturing, you simply design, do some little parameter setting, and then send it to the printer. So it will take less time. But if you just consider the fabrication step, the time you are spending on the machine, it's much less for the CNC machinery, CNC machines, but it's quite, as you have seen in the bunny example, the time you spend on the printer or on the additive manufacturing machinery is much higher than the CNC machines. So in summary, for the whole design and fabrication pipeline, additive manufacturing is much better in terms of speed, but for the time you are spending on the machine, CNC machining is much better. Yes, there are other issues. Your friend said that as the part gets more complicated, additive manufacturing will be much better. Yes, since if the complexity of your part is getting higher, then that means you need to spend more time on fixture design, more time on mounting your part, arranging maybe some global axes, some different axes, or arranging the sub steps. It will take lots of time. So but for simple parts, or if it's just a cylindrical part or a box-like shape and you have a single hole, yes, CNC machining may have some advantages, but for complicated parts, it's better we use additive manufacturing. If you have these two machines in your company, you should prefer additive manufacturing.
Hocam bir şey sorabilir miyim?
Yes, go on.
Repeatability konusunda nasıl kıyaslarsınız?
For instance, if you consider the metal parts, still we have some difficulties in terms of repeatability in additive manufacturing, since you may have some less quality powders. The initial materials is highly important, and the atmosphere is highly affecting the quality of metal additive manufactured parts. You may have, let's say, a higher temperature during the manufacturing. This will directly affect the quality. But repeatability is much better in CNC machining, since what you do, you always have the same block, you do the machining, but there you need to consider the quality of your tool, quality of your access control. If we assume that they are all the same, then I can say that the repeatability in CNC machining these days is better. But there are many researchers working on additive manufacturing, on the repeatability, on the quality of additive manufacturing, and in probably 5 to 10 years, we will have probably the same repeatability with additive manufacturing. Thank you all up to any other questions, guys? The dimensional accuracy is also the same for the repeatability. Since in additive manufacturing, we have high temperatures. Even in these FDM parts, for instance, I have an assembly here. I will show this one, the details of this one in the third week while discussing the extrusion processes. And I have another part. And I designed this, it's not designed, I downloaded these two, the white part and the red part. And I printed all of these in the same printer, but I couldn't put it here. It didn't exactly fit into there. I need to do some post-processing. Right now it fits, but initially it didn't fit. Why is that? Since in this material extrusion process, we are extruding the material at high temperatures, and once the part cools down to room temperature, that happens shrinkage. And once it shrinks, the geometrical dimensions will change and you will lose your dimensional accuracy. So for assemblies, you should be careful about the dimensional accuracy of the additive manufacturing part. And it's also the same for the metal ones. You need to do some post-processing, especially it's a part of an assembly. If it's a single product, it's fine. If you look at here, the outer surface quality is not that good. We have another one. This is a different technology. You can see the high surface roughness on this. Sorry, this is yes. On the letters and on the logo, you see we have high surface roughness. So if you want to decrease that roughness, you need to do some extra machining operations. So let's come to the complexity. What do you think? Which one is better in terms of fabricating complicated parts? Yes, this is an obvious actually answer. Additive manufacturing is much better in terms of part complexity. You don't have any limitation. Let me bring you a part. I have a gyrate example. Then you see this part. It's a very complicated piece, and I printed it, I think, in 2 days. It used lots of support structures, but the thing is that I use water-soluble support structures, and after getting this part out of the printer, I put it into a water box, and in just, let's say, 1 hour, I had this complicated shape. So if you consider AM, you don't have any limitation in terms of complexity. The thing is that you need to use proper support structures, and then once you get rid of the support structures, you can have any design fabricated. But for CNC machining, as you know, there are many difficulties. You need to have proper tools. You shouldn't have any collision with the parts of the initial, let's say, volume. Parts collision is a big issue in CNC machining, but since in additive manufacturing, we do slicing and then print each slice one by one, you'll have no collision with the equipment of the additive manufacturing machinery. Yes, accuracy, we discussed accuracy. Dimension accuracy is better in CNC machining, but there are improvements. There will be improvements on the additive manufacturing side. And in order to actually overcome this disadvantage regarding the accuracy, these days people are actually working on hybrid systems, hybrid additive and subtractive machining platforms. We have a project about it. We have finished our machining today. I may show you later. We have a new hybrid system in the laboratory, which is doing additive manufacturing and CNC machining at the same time. So if you combine these two processes together, then that means you'll be using the advantages of the two processes at the same time. You will have highly complicated and accurate parts once you use such hybrid systems. I will talk about water-soluble supports later while we are discussing the fused position modeling. So the geometry is somehow related to complexity, so we can have any type of geometries. We don't have any limitation in terms of geometry. Additive manufacturing gives us high freedom. We can print, we can manufacture any geometry, any internal geometry even. What about programming? Which one requires high programming? What do you think? In which type of manufacturing processes we spend more time on programming? Yes, CNC machine requires more programming. There are softwares which are generating the G codes in an automated manner, but still you need to define at least the sub steps: face milling, and then drilling, then tapping, then shoulder milling. So you need to actually give some lots of clues to the software so that it will generate the final machine file. But in the additive manufacturing, you don't need to do any programming. What you do, you'd set some parameters, and then the G-code file or the machine file will be generated in an automated manner. Any questions, guys, about this comparison? We have an example here. This is a teacup actually we discussed while discussing the design and fabrication pipeline. Since, as you see, it has many features which are difficult to be manufactured on the CNC machines. We have a cavity here. By using a cutting tool, it will be quite impossible to go into deeper size of the teacup. Or another thing, we have such sharp features here. You need to have a special tool for that. But if you consider additive manufacturing, we are using a single tool, single extruder or a single laser. With a single equipment, you can manufacture this whole product. But with CNC machining, and if you want to produce such a part on your CNC machine, you need to switch to different tools from time to time. And since we have a curved surface here, it's better you have 5-axis machining capability. Otherwise, it will be difficult or impossible to have such a formed surface. Another thing, you need to use a fixture. You need to hold your initial workpiece in place. So it will be impossible for you to machine these low regions. But in additive manufacturing, once it stick to the plate, it's not a problem. You can directly print or manufacture this teacup. And for the comparison, we have a nice web page. You can have a look at here. Let me share the contents with you. Now I will share the web browser. Yes. So I'm not going into details of this website, but it's better you go it on your own. It's again from 3D Hubs. It's comparing 3D printing or additive manufacturing with CNC machining. Here you have an introduction about some processes. So selecting the right technology is highly important, depending on your, as I mentioned in the previous slides, depending on the number of products you are going to manufacture and the quality or the complexity of your parts, you should decide on the best manufacturing process. For instance, we have a nice table here. If you are producing just a single, maybe few of the products, then you should use 3D printing. It's a plastic one. But if it's a metal one, then you may have to use maybe CNC machining or metal 3D printing, depending again on the other requirements you have. But if it's some tens of products, then you may consider CNC, but 3D printing might still be okay for the plastic parts. Again, still you can use metal 3D printing or CNC machining for the metal ones. Again, you should consider other issues like surface quality, manufacturing time, so it will be up to your requirements. But for the plastics, if it's around hundreds, it's better you start considering the injection molding. Still, you can do CNC machining, but you need to spend lots of time on mounting, demounting your parts. So I would prefer actually injection molding after I see the numbers about 200, 300. But for thousands, you don't have another choice. For the plastics, you should just use injection molding. For the metals, if the number is high, you should use the counterpart of the injection molding. And for the metals, you should use die casting or maybe investing casting. But if the part is around hundreds, then you may do it with CNC machining. So here, other considerations are written here. They are depending. You should check the tolerances, the tool thicknesses, the part sizes. So depending on the properties of your part, you can select the best manufacturing process. So you may have some requirements about the materials, CNC materials, some 3D printing materials, the part complexity. So we said that there might be some geometries which are impossible to fabricate on the CNC machines. So if that's the case, then you don't have any other choice. You should use additive manufacturing. So in summary, this is your homework. You should go through this website and check the rules, which one, depending on the complexity and the quantity, which one will be your best manufacturing